Hello and welcome to our stats notes for section 3.2. This section we're going to talk about measures of variation. So last time we talked about measures of center. We were looking at things that kind of measure the middle, the center of a set of data. And so let's just kind of go back and see a few of those again, just review that. So here I have two teams of basketball teams, just 5 players in each team. I've got the heights for all the players in each team. So team 1, here's their heights, and team 2, here's their heights. Now, if we look at these two teams, you can see there's a little bit of a difference here, right? You can see there's like some short guys on this team, but also some really tall guys. These guys you can kind of see are all kind of in the middle range, all 6 foot to 6'6". This one's 5'7". That one's over 7 foot tall. Okay, so let's look at the mean, median, and mode for these two sets. So first, if I want to find the mean, remember to find the mean, I have to add up all the numbers. So I'm going to use the inches because that'll be easier than trying to work with feet and inches. If I do this first team, I do 72 plus 73 plus 76 plus 76 plus 78, and then divide that by the 5 players on the team. I see that this team's average is 75. And if you do the other team, add up theirs and divide by the 5, you end up finding out they have the exact, 84, last one, the exact same average. So both these teams, their mean is 75. If you look at the median for these two teams, remember the mean is the middle number. This team, the median is 76. This team also, the median is 76. Mode, remember, is the most common one. So there's two 76s on this team, so that's the mode. Two 76s on this team, that's the mode. So you'll notice that these measures of center all come out the exact same. So even though these teams look different, if you look at their center, what's typical, they have the exact same measurements for center, for typical. So the center and typical is not the only thing we like to measure. There's more to measure with a set of data. Beyond what the average or the middle number is, we want to think about, is the data more spread out or less spread out? And we call that variation. It's the spread of the data. That's what variation is all about. How spread out is the data? And you can pretty clearly see that Team 2, their data should be more spread out than Team 1 because they have people, under 6 foot and people over, all the way up to 7 foot. There's a lot more spread there versus Team 1. So when we measure variation, we're measuring the spread of the data. Measure the center is one thing, but we want to measure the spread. Now, the first and the easiest way to measure the spread is with what we call the range. So the range, pretty straightforward, pretty simple, is just subtract the minimum from the maximum. And it's the simplest measure of variation or spread. So you just take the top number, subtract the bottom number, that's your range. Like if I have this set of data right here, biggest number is 7, smallest number is 4, so we use 7 minus 4, and we get 3. And that's a pretty easy way to measure spread. Now there's a 3 spread from the top and the smallest number. And the bigger the spread, the bigger the range, the more the spread is. So this next set, so of course the top number, all these 6s are all the top, so I'm just going to use the first one, and then 3 is the bottom. So we do 6 minus 3, and we see that that's also 3. Now that looks kind of fishy, because this first set, you can see there's kind of variation. We've got 5s and 6s and 7s and 4s. This set, all we have is 1 3 and a bunch of 6s. There's not really a lot of spread. Most of the time, there's just this one number. And that number is so different, you notice that we would call this an outlier, right? We said those outliers are numbers that are way different than everything else. And so you'll notice that because we had that one outlier 3, we got a pretty big measure of range, of spread on this one, the same as we did over here, even though these numbers are typically not that spread out, which is why the range is not a resistant measure. It does really get messed up by outliers. So it's not resistant. Since it really depends on the top and the bottom number, and that's it. It's a lot like mid-range we saw last time. It just depended on the top and the bottom number, and that's it. So it's very bad. It's not a good measure. People don't typically use this. If you know your set doesn't have any outliers, it might be a nice, quick, easy thing to measure. But in real life, it's not something we're going to use very much. It's just not a good measure. So we have other ways to measure spread. And probably the most common, typical one, the one we're going to use the rest of the semester the most, is the standard deviation. So standard deviation is a way to measure the spread of the data. What it does is it takes all the data values in your set and measures how far they are from the average, from the mean. We'll use the mean to calculate the standard deviation. And then you measure those spreads, and then you average those distances. And so we call them deviation. The deviation is the distance of a data value from the mean. So we calculate all the deviations, and then we average those deviations. And that's why this is called the standard deviation. It's basically kind of an average of all these deviations. Now your book will give two different ways to calculate this. So there's two different formulas. This formula over here is going to be the calculation formula. And so like if you were writing a stats program and you wanted to write a program that would calculate the value for the standard deviation, you would use this. And this version is a little bit better because there's less rounding. And less rounding is always better when you're trying to get a more specific or precise answer. But we're not really going to use that because if we wanted to be more specific and worry about rounding, we'll use technology to get our answer. If we're just using a formula, we'll actually use this one because this one is good enough for us. It's got some rounding in it, and so it's not going to be perfect, but this is the one we'll use. So we'll use this one. Okay, so you notice the notation here. We see those x sub i's. Remember, that's all the data values. That's what this x sub i's are. X bar, remember from last time, is the mean. So this is the mean we're talking about. All right, maybe it was 2 times ago, but they're going to find all the different data values, subtract the means from all those. We're going to end up squaring all those after we subtract, so the part where you square. You'll add those all together, because you always add up before you divide when you're averaging. And you'll divide. When you do sample standard deviation, you notice that we don't divide by how many numbers there are, we actually divide by one less. Remember, n is the number of values. So n minus 1, we actually divide by one less. That's a weird little quirk for sample standard deviation specifically. And then we'll square root that to get rid of the squaring at the end. And that will give us our sample standard deviation. So S stands for the sample standard deviation. So this is the process again. First, we'll find the deviation. That's where you take each data value, subtract the mean. And then we'll square the deviations. We're going to square all those numbers. We do that because it makes them positive. If you add up a bunch of negatives and positives, you end up getting 0. So we square them all to make them all positive so we don't get to 0. And then we'll sum the squares. We'll add them all up. And then we'll divide by 1 less than the number of values. And then we'll square root it to go back and get the answer. So let's show this process. I'm going to show this with these numbers here. First thing you have to do is find the mean, which if you notice, these numbers are the same numbers we had for that team 1. So this is team 1 right here. And so we already know that the mean for this set is 75. So the mean, x bar, is 75. That's from page 1. So first off, to find the deviations, we're going to take every single value and we're going to subtract the mean. So we're going to take each one of these and subtract the 75. So we're going to have 76 minus 75. I got 1 for the first deviation. Take 72 minus 75. I get negative 3. Notice we're getting positives and negatives. I'm going to take 73 minus 75. Get 2. I'm going to take 78 minus 75. 3. 76 minus 75, which we've already done, but we'll do it again. And again, we'll get 1. And those are the deviations. So the deviations, again, each one of these is measuring how far a number is from the mean. Some of them are above. 76 is above the mean, so we get a positive. Some are below. 72 is below the mean. It's less than 75, so you get a negative. But all these numbers, you'll notice, if you add them all up, you'd get 0. This would add up to 0 because the mean's in the middle, so it makes sense. You know, if you have some numbers above, some numbers below, they're going to cancel out. You're going to end up with 0. So what we do next, because we don't want 0, is we take the deviations and we square them. So take 1 squared, I get 1. That one doesn't change much. Negative 3 squared gives me 9. Remember, when you square a number, you multiply it times itself, and a negative times a negative is always a positive. Negative 2 times negative 2 gives me 4. 3 times 3 gives me 9. And 1 times 1 gives me 1. And those are the deviations squared. So first we found the deviations, right? That's what we did here. We got the deviations. Then we squared the deviations, so we squared them. The next thing we do is we sum up those squares. So we're going to add those all up. And this will be the sum. So 1 plus 9 is 10, plus 4 is 14, plus 9 is 23, plus 1 is 24. So I get 24. That's the sum of all those deviations. Next thing, we divide by how many numbers there are, minus 1. So in this case, their n was 5, because there's 5 values, so n minus 1 is 4. So I'm going to take that 24, I'm going to divide it by 4. So we get 6. So 6 is what we get for that. After we divide by n minus 1, so one less than the number of values, last thing we do is we're going to square root that. So we're going to take and we're going to square root 6 to get our final answer. So here I'm going to pull out my calculator. I can't do the square root of 6 in my head. So I'm going to use the second square root button. So that's square root down here. And it's got a little x squared in the front, and there's a little square root symbol above it. So second square root is 6, and we get 2.4. It's like 449. I'm just going to round to 2.45. My lab will tell you what to round to, so you just round to what's specified. These scores, standard deviation, I think a lot of times you do 2 decimals is pretty practical. If they ask for more, you can do more. If my lab asks for more. But that's our standard deviation. So standard deviation, again, this is a measure of the spread of the data. So we saw, some of the numbers were spread out by 3, some were spread out by 2s and 1s. This is kind of an average of that. So you can see how it's in the middle of these different deviations. So this is a way to measure the spread of a set of data. It's a lot better than the range because it's not going to get quite so messed up by outliers. It does still get affected by outliers a little bit, but it's a bit more resistant because it takes all the numbers into account, not just the top and the bottom. Now this calculation gets to be kind of time consuming. You can see we only had 5 numbers and they had a pretty big set of work to do. So thankfully, we don't really have to do this by hand very often. In fact, your calculator will find the standard deviation for you. So we'll do that on the next page. So the next page, let's talk about using the calculator to get standard deviation. So, the method we did by hand, it's kind of time consuming. In real life, we're just going to use computers or calculators to find the standard deviation. So we're going to use a calculator to find these. So I've got 2 data sets here. I'm going to put the first set in my list 1, the second one list 2, and then we'll use these data sets to find the standard deviations. So remember to put the data in your lists. You're going to go to the Stat button. You're going to go to Stat, and you're going to hit Enter on the Edit option, and then you have your lists, list 1, list 2, all that. So that's where your lists are. So I've got list 1, list 2 here. I did show you guys last time, I think it was actually 2 times ago, how you can kind of delete these lists, and I deleted one, and I couldn't remember how to get back in. Well, I'll just show you. The way you get it back in is you just keep deleting, because eventually you'll have blank spaces, and that's where you type. So if I want list 3 back, I just hit second list 3, enter, and now I've got list 3 back. So if you ever delete a list, you can actually go back and put it in just typing that second and then the appropriate number down here. We really don't need anything more than list 1, list 2 in this class usually. There might be a couple times where you might use more lists. But yeah, just so you know, you can always go back and put those back in. I think you can even rename the lists. I never do because I think that's just silly. I just like list 1, list 2, that works for me. Here I went in and I typed in already, but you could do that right now. Type in the 41, 44, 45. So if you want to pause the video, just type those in real quick. You can do that. Put list 1 and list 1 and list 2 and list 2. And then we're going to calculate the standard deviation for this. So the way to do that, we're going to hit the Stat button, and we're going to arrow over to Calculate. So we use Calculate option a lot when we want to calculate something from a set of data. Since I want to calculate that data from just one set at a time, I'm going to do the 1 var stat. So it's one variable, one set of data. So I'm going to hit enter on that. Now I want to use list 1 first. So I'm going to get an answer for data set 1. So I'm going to leave that as list 1. You can leave the frequency list blank. We don't need anything in there, so just leave that blank. And hit calculate. And now it gives you data, or statistics about that first set of data. So lots of things here. It gives you like the mean is 50, so I actually found the average for that set of data. The sum is 500, so I actually took all those numbers and add them all up. The n here, that's how many values there are. So you can see there's 10 numbers. The minimum number, so 41 is the smallest. The maximum number is 66. So it gives you a lot of different numbers. The median, that's the middle number, 47.5. So even if you don't have a set of data in order, you can just type in your calculator and it'll find the median for you because it puts it in order itself. The one you actually want right now is the sample standard deviation. We use S for standard deviation, for sample standard deviation. And so that's the number we want, the 7.408, or you could round it to like 7.41. That's going to be your standard deviation. So SX is what the calculator puts it as, at 7.41. Again, a lot of times we'll just use plain S. Your calculator likes to put a little X there because it's the standard deviation of the X numbers that you had. So again, to do this, we're going to do, stat. We're going to hit the Stat button. we're going to do edit and then enter the list. So we're going to enter all the values. And you're going to hit stat, calculate, and then 1-bar stats. And again, once you hit that, when you hit that stat, calculate 1-bar stats, just make sure you have the right list in there. So if you're doing list 1, make sure it's list 1. When you're ready for list 2, you just hit second, type in list 2. So I got list 2 in there. And now I can go ahead and calculate, and it'll give me the data for the second list. Second list actually also adds up to 500, has 50 for a median, but you can see it has a much different standard deviation. Now it's 14.16. So the standard deviation for this set is 14.16. That's the standard deviation. So you can see how this data set down here is a lot more spread out. It goes all the way from 20 to 70. This one only goes from 40 to 66. You know, the range would be different for these two. But the standard deviation, again, is the better measure, so it doesn't get messed up by those outliers. So you should be able to find the standard deviation. Using your calculator is a really good way to do it because you can see it's a lot more straightforward, simple. You don't have to sit there and do all those calculations. So on the test, you're welcome to just always use your calculator to get your standard deviation. I'm not going to make you do it by hand. That's not something I really believe that you have to do. If you're doing this in real life, you're going to use a calculator computer program to do this. So. Now that was sample standard deviation. So remember, sample is when we're taking a small part of the population and then calculating stuff about that. Now in real life, you also might have to do population standard deviation. So there's the spread of the data for the entire group. That's the population value. And the calculation is a little bit different. It's not hugely different. The big difference is what's on the bottom of the division. So instead of dividing by n minus 1, you actually divide by capital N, which remember is the entire population. So in this case, we don't subtract 1. Now because of that difference, though, that difference is enough that if you use the wrong calculation, you're going to get a slightly different answer, and so things are going to get marked wrong. So if you're looking for population, you have to do the calculation differently. Thankfully, we can still use a calculator to do this. So your calculator actually gives both. It gives both the sample standard deviation and the population standard deviation. So if we look back at the calculator results we just had of my 1-bar stats, okay, calculate, we can see that we had the sample standard deviation with SX, which was 14.15, and then we had actually this number below it, and that's actually the population standard deviation. So we use this letter here. It's called, I believe that's lowercase sigma, if I'm remembering right. I don't know why I can't think of it right now. I'm probably calling it the wrong name. I'm just like, my brain just is freezing on it. But that's the sample standard deviation symbol. It's a Greek letter again. I'm not going to test you on your Greek, so hopefully you'll forgive me if I messed up mine. But that symbol right there, that's the lowercase, letter, Greek letter that we use for population standard deviation. So we like to use Greek letters for these population values. So that's the same letter here. So this is population standard deviation. And so we'll use that. We'll look for that symbol like that with the X for population on the calculator. All right, so going back to our data set 1 and 2, we can calculate for set 1. I put in my list 1 on here again, so put in my list 1 and then calculate. We can see that the sample was 7.4, but the population was 7.02. So for data set 1, the population standard deviation is 7.03 is what it rounds to, because the 8 rounds it up to a 3. So it's a little different from 7.41 to 7.03, just a little bit of a difference. But again, that's because we have a calculator. We can do that. So use your calculator, it provides both, just use the correct one. So this is your population standard deviation versus your sample standard deviation, S. Usually we'll do S. That's kind of the more common one. You should be ready to do population every once in a while. And again, I probably won't make you ever do this by hand. You can just use your calculator. For the second data set, again, I'm going to go back to my calculate option and just do my 1-bar stats, but make sure it says list 2 now, because I'm doing that second list. I already talked about this, so just, should already remember this at 13.43. So 13.43 is the population standard deviation for data set 2. So again, it's a little bit different than that 14.16 we got earlier, just because we're calculated a little bit differently. So that makes a little difference. So population value, sample value. That's the big difference. Okay, let's talk about the range rule of thumb. So the spread of data is important. How spread out the data is something that's very important, and we can actually tell a lot just by looking at things like the standard deviation. If we know that, we actually tell a lot about the set of data. So almost all data values, not all of them, but almost all of them, are within 2 standard deviations of the mean. So if you think about the middle, the mean, and you say, okay, I know what the standard deviation is. Say pretend in a problem it's 10. And if you go up 10 2 times, so you add 20, or if you go down 10 2 times, so you go down like 20, within that range, you're going to have almost all the data values, because that's how strong the standard deviation is. Most everything is going to be within 2 standard deviations of the middle, the mean. So within 2 standard deviations, you got to say that stuff is what we expect to have. Now, if you do find values that are outside, beyond that 2 standard deviations, stuff that's on the ends, that stuff we're going to say that's so unusual, obscure, we're kind of surprised by that data. So we'll actually call it either significantly high, if it's on the high end, more than 2 standard deviations above the mean, or significantly low, because it's 2 standard deviations below the mean. This stuff, it's kind of unexpected. We don't expect much values to be out in that range. Okay, so we're going to figure this out for ourselves. We want to look for things that are significantly high or significantly low. Again, that's values beyond 2 standard deviations for this data set right here. Now to do that, we need to know what the mean is. So we're going to look for the mean. Remember, the mean is the middle. This is the mean. And then we're going to use that to add, and we're going to add the standard deviations, right? So we're going to go 2 standard deviations up or down. So we can figure out what the standard deviation is. We're going to find that standard deviation. So for this data set, I'm going to go ahead and throw up my calculator again. Yeah, there you go. There's all the numbers. I'm going to go stat, edit, and I'm going to go ahead and clear this out. So I'm going to go to L1, hit clear. Don't hit delete. That's hit delete. Remember, it makes it go away. So I hit clear and enter, and that's right there. I'm going to type those values in. So 38, 48, 17, 61, 89, 49, 63, 7, 58, 49, 54. So type those in, and then I'm going to hit stat, calculate those 1-bar stats. Make sure I'm on list 1, because I just put that data on list 1. Calculate it. You can see that the mean for this one is 53. So the mean is 53. In this case, the mean, remember, you can use the mu label for mean when you're talking population mean, or you can use the x bar mean. So they don't really mean a different thing. So in this case, we're using, x bar or mu. I'm not really picky about that. So maybe I should call this mu, even though on the calculator it's called x bar. But it's the average for that whole set of data we have. And then if we look at the standard deviation, being this second one, the population one, would be the 16.7. So standard deviation is 16.7. I'm not going to go more than that right now, just because any more than that's going to make it a little more complicated to calculate. So I'll just double check if I got those values in right, because that feels weird. I don't want to say the number's supposed to be different than that, but sometimes you type a number wrong, so it's better to double check. Nope, it looks like we're okay. Okay, so 53, is our mean. 16.7. Yeah, last time I used 17. Maybe I'll be, that's too late. We already used 16.7. Okay. So now what we can do is we can figure out if any of these values are significant, if they're unusual, by taking the mean, 53, putting that in the middle, right? So 53 is in the middle. And we're going to go out 2 standard deviations up and down 2 standard deviations, and then figure out where kind of the cutoff points. Where's the cutoff before you get to the weird stuff. So we take 53, and I'm going to add 2 of these 16.7. So I'm going to take 53 plus that 16.7, but I'm going to double that, right? Times 2, because I want to add 2 of those, and that'll put me at 86.4. Because what I'm doing is I'm taking 53 and I'm adding 16.7 2 times, which is, I'm adding like 33.4. So I'm adding to get that higher number. To go the other way, I'm going to subtract. Right? So I'm going to subtract 33.4 to go down. So I have 53 minus 33.4. And I'll see that the low cutoff is going to be the number 19.6. So what this tells us is that numbers below 19.6, that's going to be low values, or the significantly low are going to be numbers below 19.6, and significantly high are going to be numbers above 86.4. So look at my data set and I see 17. 17 is significantly low because it's below that 19.6 cutoff. We don't expect to see much numbers below that. Numbers above 86.4, well, 89 is going to be significantly high because it's above that cutoff of 86.4. So we just don't expect to see numbers above 86.4. You go out 2 standard deviations, you kind of expect to have all your numbers, and here we found 89 above. And I think that's it, right? So 61, 48, those are between 63, 57. Yeah, so the rest of these are on the 50s and 60s. They're all less than 86 or more than 19. So those are the only 2 numbers that are significantly low, significantly high. Again, we don't expect to find many of those. I think I had to really work hard to make a problem where it had both, because most data sets are not going to have much, if any, of these numbers that are significantly high or low. Most numbers are going to fall in that middle range. Okay, so that's the range rule of thumb. This is kind of a little tool we can use so we can think about, again, most stuff is in the middle. If you go out 2 standard deviations, you're going to get to the range of stuff that's kind of significant. And this is an important thing. We'll see it come up throughout the semester. There's this idea of significance and this idea of being unusual or unlikely. So numbers that are kind of far out from the middle are going to be unlikely, and they're going to be significant. They're going to be important. Now, there is one more way to measure variation. This one's called variance. So variance, again, is another way to measure variation. Variance is actually related to standard deviation because the variance is actually just the square of the standard deviation. So you just take your standard deviation, multiply times itself, and you get the variance. That's variance. So if you take the sample standard deviation and square it, that's sample variance. If you take the population variation and square it, that's population variance. Now, variance is actually commonly used. So if you go and get a degree and go into doing statistics full-time as a job, you use variance all over the place. It is a resistant measure, so it's not going to get messed up by outliers. So people really like it. But the label, so when we work with real numbers and we have labels, like if it's number of hours or miles or stuff like that, the label for variance, because it's squared, is going to be weird. It's going to be different. It'd be like hours squared or miles squared. It's kind of unusual and weird to work with. It kind of makes the work hard. So we're going to avoid it for this class, because again, we're just interested in statistics. We're not trying to get too hard in this class. So we're just going to mostly work with sample standard deviation or population standard deviation, because it's a little bit easier to work with. It feels a little more natural because it matches the numbers. So we'll talk about how to find this once, but we're really not going to use this a lot this semester. Variance is something we'll leave for the Stats 2 course, really. Okay, so first off, they want to find the population standard deviation. They tell us the population standard deviation is 12.4, and they ask us to find the population variance. So to find the population variance, again, population variance is just the square of the population standard deviation. So the standard deviation for this population is 12.4. So the variance is just that squared. So we just take that 12.4 and square it. That'll give us a variance. 12.4 squared, there's my squaring button, is 153.76. So that's the population variance. We want to get the sample variance. So the sample variance, we're going to take the sample standard deviation, which is 13.1, and we're going to square that. So the sample variance, we're going to take the sample standard deviation, 13.1, and we're going to square it. The sample variance is just the square of the sample standard deviation. So 13.1 squared. Square that in my calculator, I get 171.61. And that's your sample variance. And again, it's just the difference between the population value and the sample value, because those calculate a little bit differently. That's why you calculate them differently. But that's it. So variance is just the square of the standard deviation. So if you have the standard deviation, it's pretty easy to find, to get that sample or population variance. You just have to square the standard deviation. Okay, last thing for this section. So there's this cool little rule. It's called the empirical rule. I've seen other people call it the 68, 95, 99.7 rule. And it's just a trick for figuring out the kind of percentages across this grid of the different values. So if you take a normal distribution, this only works for a nice normal distribution. Like I said before, we like normal distributions because they have kind of easier math. So if you have a normal distribution, and it's a nice spread out normal distribution, the 68, 95, 99.7 rule, or the empirical rule, says that 68% of your data, of the values in your data, will be within one standard deviation. So if you look at the mean, it's in the middle, right? Here's your mean. And you say, okay, if I go out one standard deviation both ways, so if we say, for example, our mean is 50, and our standard deviation is 10. So you start at 50 and go up to 60 and down to 40. Between 40 and 60 will be 68% of your data. So 68% of the results from your study will be in that middle range. If you go 2 standard deviations, you'll have 95% of the data. So if I start with my 50, you go up 10, 10, down 10, 10, down here at like 30 and up here at 70. Between 30 and 70, I would end up with like 95% of the data. So I'm going out 2 steps now. You go out 3 standard deviations, so you got 3 steps, you have 99.7. That's a lot of percent, right? That's not quite 100%, but it would round up to 100%, right? That's almost everything. So if you go out 3 standard deviations, so you got 1, 2, 3 steps, 1, 2, 3 steps, in that range you have 99.7% of the data. So anything that's more than 3 standard deviations out is really kind of rare. That's your unicorns, your blue moons, like something that you just don't expect to see, because most everything is going to be within 3 standard deviations. You can see I got almost all the data because this histogram, curve shows most of the results are in this area. There's very few at the end of the bell. Okay, so we're going to use this 68, 95, 99.7 rule and kind of figure out a couple things given this information down here. So they tell us that they have a set of data with a mean of 75 and a standard deviation of 15. So if we think about this chart and we think about putting, a chart here and saying, okay, the mean in the middle is 75, and then the standard deviation, and the distance we're moving for each bar, is 15, then what would be the percentage between 60 and 90? We're going to do percentage between 45 and 90, and the percentage between 60 and 120. And we're going to do all 3 of them. So I made myself 3 different little graphs here on the next page. So we can do each one by itself. So we're going to start off with the first one. We're going to go from 60 to 90 for the first one. And again, we said the middle value, the mean, is going to be 75. So the mean is 75. So right in the middle, we're going to label this as 75. It's going to be 75 on all 3. So I'm going to just label it right now. So 75 is the middle. And then we're going to say the standard deviation was 15. So every time you go up a bar, you add 15, right? So this next bar, you go 15 more than that. So that's 75 plus 15 is 80, 90. This could be the 90 bar. And the next one's going to be 15 more than that again. So this is going to be 105. So you add 15, you get 105. Add 15 more, you get 120. And it does keep going. There are values down here, but there's just not very many, right? Because we said almost everything is between 3. So go down. Now instead of adding, I'm going to subtract. So I take this mean 75, subtract 15. You get 60 here. Take 15 away from that, you end up with 45. And 15 away from that, you end up with 30. Now I got labels. And again, remember this middle region here is 68%. If we go out to here, this whole region is 95%. If we go out to here, this whole region is 99.7%. And because this is a bell curve, it is symmetric. So the 2 halves match exactly. So these half here and this half here, they do match. I want to find a region that is 60 to 90. I'm looking for the 60 to 90 range. So I'm looking for this region right here. That's not too hard, because if it's between 60 and 90, well, since it's just this region in the middle, that is always the 68% region. So this one, I want to know what the percentage is between. Well, the percentage is 68%, because that's only 1 standard deviation each side, 1 standard deviation. And so that's the range that includes 68% of the data. That one, we're done. That's it. We just had to find the 60 to 90. Let's try the next one, though. The next one now is going to go from 45 to 90. So if I label everything up again, so this one's 90, this is 60, this is 45, I can see now this time I'm looking for the range from here to here. So what percentage shaded this time? That's what I'm looking for. I don't care about the 30 down here or the 105 or the 120. I just care about from 45 to 90, this region. That's what I'm looking for. Now I can't just say 68% because that would just be these two. I have this piece as well. So there's a couple ways to do this, a few different ways. One way is to figure out what this piece is and just add it onto your 68. And that's not too hard to do. Another way to do it would be to figure out this whole range and just take off this piece. That'd be another way to do it. So there's a few different ways to do it. So first thing I'll do, I think I'm going to figure out what this piece is. Since these two pieces are the same size, they match. Figuring out this is the same as figuring out that. So that's why it doesn't really matter which way you do it. So I need to figure out what one of these pieces are. So to do that, I'm going to say, well, this whole range from 45 all the way to 105, that would be 95% of the data, right? So from 45 to 105, because that's 2 standard deviations, is 95%. If I take away the middle 68%, I'm left with these two pieces. So take 95 minus 68. I'm going to do 95 minus 68. And that's going to find these two pieces over here. So 90 minus 60 is 30. 35 minus 8 gives me, what, 27? That's 27%. So 27% of data is in these two pieces. But because we said this is symmetric, this thing matches, these two pieces are the same size. So I can take that 27 and cut it in half. I'm going to take 27, divide by 2, and that's going to tell me how big these pieces are. So 27 divided by 2, I get 13, right, 13.5. Yeah, so 27 divided by 2, I get 13.5. So that tells me that this region here, or this region here, either one of those is 13.5%. So now I can use whichever I want to. I can take 68 here and add a 13.5 and get my answer. Or I can take 95 and take away a 13.5 and I'll get the same answer. So it really doesn't matter which one. I think I'll just take the 68 and add the 13.5. That's a little bit easier to do in my head without pulling out my calculator. So I just took the 68 that's the middle two, because the middle two is always 68. Add this piece, which we figured out was 13.5, and now gives us our answer. So if I add 3.5, that gives me 71.5 plus 10 gives me 81.5. Hopefully I did that right. So double check myself. 78 plus 3 is 81.5. So that is the region. It should be bigger, right? 68 we started with, we added another piece on, so we got something bigger. That makes sense. If I've done 95, if I go back and do it the other way, if I do 95 minus 13.5, I get the same 81.5. So you can do it either way. You can start with a big piece and take away a piece, or you can start with a small piece and add on a piece. But either way, you should get 81.5. So it's empirical rule. A lot of times to do this empirical rule, you have to think about bigger sets, like this whole 95, and either take away a piece you don't want, or you take a small set like 68 and add on a piece you want. A lot of times you have to take the differences between things like the 95 and the 68 to be able to think about what these smaller pieces are. And use that divide by 2 because, again, these match. So as soon as I know what both of them are, together they're 27, I can divide by 2 and find out what each one is separately. Okay, we'll try one more. Let's do this in a different color just so it doesn't get confusing. So this one, we're going to go from 60 to 120. So again, if I label this, I got 75, I got 90, I got 105, I got 120, I've got 60 down here. So that's the region I'm trying to get this time. So I'm actually trying to go all the way from here to here. So I'm doing all this stuff all the way here. So I want to get from 60 to 120. Now this time you'll notice 2 standard deviations would just be that. 3 would be all the way, or sorry, 1 would be that. 2 would be this. This one goes all the way up to 3. Now, doing this, I've got all these pieces to get rid of. I probably won't want to try and find the standard, the whole thing 3 and then like take away 2 pieces. It'd actually be easier in this case just to find this piece and then add just this one piece, because those are going to be easier. So what I'm going to do in this case, I'm going to think about how 3 standard deviations would be at 99.7. 99.7, that's the whole way from here to here. But if I cut that in half, I just get one side, and that will give me this whole piece here. So I'm going to do that, divide by 2, and that's going to give me this side from here to here. This is going to be 99.7 divided by 2, which is, type in my calculator, 99.7 divided by 2, 49.85. So that's this piece on that side is 49.85. And I just have to add on this one piece, and I've got the whole thing. Well, thankfully, this piece is easy to find because we know the middle two pieces is always 68. So half of the middle is going to be 34. So take the 68 and divide that by 2, and the 34. This piece right here is the 34, just this piece right here. So now if I take the 34 from this piece plus the 49.85 for that piece, add that together, I've got the answer. So 34 plus 49.85, give me my answer. 34, 49.85, type in my calculator real quick, I got 83.85. You notice this isn't much bigger than our last answer because even though we added on a piece over here, these ends are so small, it doesn't make this go up a whole lot. The ends are not very big. Most of the stuff is in the middle area. But that's the idea. So it's kind of a weird process to get used to. Really pay attention to what halves are, because remember this is symmetric, so you can always think about halves and stuff. We're not going to do a lot more with this later on, because this is actually more of an estimation tool than getting exact answers. So you'll see that we'll end up with doing stuff similar, but will be more precise, more exact later on this semester. But this is a good estimation tool. It's a way to think about the amount, kind of, not exact, but kind of get an estimate amount. So, all right, that's it for 3.2. So 3.2, you should be ready to work with this empirical rule, with this bell curve. So you have this normal, nice bell curve, and you're looking at that 68, 95, 99.7. You should be ready to use that range rule of thumb and know that there's significantly low high values when they're more than 2 standard deviations out. You should be able to find variance by squaring the standard deviation. You should be able to find the population or the sample standard deviation. Again, we're just going to use the calculator, so you just have to know which one's which. And you should be able to, again, you don't have to do the standard deviation by hand, so don't really worry about that. You can use your calculator for it, and I'll always let you do that. But you should be able to find the range. You should know how to find the range just by taking the top value less the bottom value. Again, those are just all ways to measure variation. How spread out is the data. So that's it for today. I'll see you on the next one.